Hello, today we're going to talk about trend lines and predictions with our scatter plots. And predictions is pretty easy. We're just going to look at what they have and see if we can predict what to expect past that point. So we're going to talk about trend lines first. When a scatter plot shows a linear association, you can use a line to model a relationship between the variables. And we did that on the last lesson. A trend line is a straight line that comes closest to the points in a scatter plot. It says Joyce is training for a 1K race. For some of her training runs, she records the distance she ran and how many minutes she ran. And so we're going to take that data from that table and we are going to create a scatter plot of Joyce's data. So at 4 miles, she had 38 minutes. So at 4 miles, she had 38 minutes. And so that's going to be, get back on the right line, about here. 2 miles and 7 minutes. 2 miles and 7. 1 mile. Oh, sorry, that 2 miles is 25. 2 miles, 25. 1 and 7. 2 and 16. 3 and 26. 5 and 55. 2, 20. 4, 45. And 3, 31. So when I take a look at this, I can tell that it's a positive association. The further she runs, the longer it takes, which makes sense, right? All right, so we're going to draw a line through these points. I think I'm going to change the color of my line to make it a little easier to see. And so the idea is to draw the straight edge line that has about the same number of points above and below it, and we're going to ignore any outliers. And so I kind of want to go, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so if I can keep like 4 on one side, 5 on the other. 1, 2, 3, and 1, 2, almost 3 there. Okay, so there's our trend line. And we can see that it is a straight positive line. And we can use this line to predict about how long it should take her to run 4.5 miles. So if 4.5 miles should be somewhere in this ballpark. And so if we just go with what's on the line, we figure it's going to take her about 50 minutes. Okay? So about 50 minutes. Now, is it possible that if she ran 4.5 miles that it would take her more or less time? Yes, it is. But if we're just predicting, it's not an accurate science, and so we can just look to see where it falls on that line. Do you think that you can use a scatter plot that shows no association to make a prediction? So remember, if we had one that was no association, the dots were just kind of like scattered all over. Can we make a prediction from a no association? No, it's too hard. You can't. There's no trend line. You know, I could find where I could put half of them here, or I could find a line and half of them would be here. But it's just too scattered. It's too unrelated. So we really can't show the prediction that way. All right, so let's take a look at this one. This is example 1. It says the scatter plot and trend lines show the relationship between the number of chapters and the total number of pages for several books. And they want us to write an equation for the trend line. So the first thing you do is you create your trend line. And so they have all the points that they had plotted from our bivariate data, the number of chapters in the book and the number of pages in the book. And so they have all these dots. Then they drew the line, and they drew the line through this point here and this point here. And I have 1, 2, 3, 4 on this side. 1, 2, 3, 4 on that side. So see how it's evenly matched? Now we can also take this information and we can come up with an equation for that line. And I'm actually going to take these 2 points that I darkened off, and I want to talk about how you would find the points on this graph. So what I've done is I'm looking for where that line passes through points that are easy to find. So I have here one at 660, and I have one here at 10, 100. They used 170 and 17 and 170, so they used this one here. And then, but that's not an easy one to figure because it's kind of not quite right there. So I pick ones on the line that are easier. So I have my 100. Now I'm going to find my slope. 100 minus 60 over 10 minus 6. And so this becomes 40 over 4, and that simplifies down to 10. So my slope is 10. Where does it cross the y-axis? Well, it crosses right here at the origin. And so I know that my y-intercept is going to be 0. So that means that my equation is going to be y equals 10x. Does that bring back memories for you? All right, so now let's take, and we got the same answer they did. What type of association does the scatter plot show? So when I take a look at this association, what is that? Yeah, you're right, it's positive. So we know it's positive, but what is the meaning of the slope in this situation? Let's take a look at this. If I have more chapters, would you expect there to be more pages? Yeah, so that's what it means. The more chapters, the more pages. So the more pages to expect. What is the meaning of the y-intercept in this situation? Okay, well, let's take a look at this. It was 0 chapters, and so if there's 0 chapters, do I even have any pages? And so that's why it's 0, 0, because without a chapter, there is no pages, if it's a chapter book. So it just means no chapters, no pages. All right, now let's take a look at the your turn, number 6. It says the scatter plot and trend lines show the relationship between the number of rainy days in a month and the number of umbrellas sold each month. And then we're going to write an equation of the trend line. So let's take a look at here, this data. So they have the number of rainy days and then how many umbrellas were sold on those days. Okay, so as we have more rainy days, what happened to the number of umbrellas? Well, they increased. And so this is a positive correlation. It's not linear so much because they are not tightly situated around the line, but it's enough to figure out what the situation is. So, and it would make sense that the more rainy days you have, the more people will be buying umbrellas. So if I take and look at the line itself, I can find points on this line and find my slope and then write my equation. So I see a point here at 10, 8, and some of them are really close. Looks like the other one is only at origin, so at 0, 0. So if I'm going to find the slope, I'm going to take 8 minus 0 over 10 minus 0, and I get 8/10. And so that would simplify down to 4 over 5. So my slope is 4 over 5. It's at origin, so it has no y-intercept or 0. Sorry, it has a y-intercept. It's at 0. And so it would be y equals 4/5 x. If you wrote it as a decimal, 4/5 is 0.8 or 8/10 x. All right, making predictions. We kind of did that a little bit already. We used information from our trend line to kind of help us come up with an idea of what to expect after a certain period of time or number of miles. So when we use the trend line or its equation to predict a value between data points that you already know, you can interpret or interpolate the predicted value. When you make a prediction that is outside the data that you know, you extrapolate the predicted value. So we're going to use the equation of the trend line from example 1 to predict how many pages would be in a book with 26 chapters. So let's go back and get that equation. Okay, so we had the equation y equals 10x. Oops, went too far. So y equals 10x. That was our equation that we had for our trend line. And we want to find out what it would be with 26 chapters. Well, if x is the number of chapters and y is the number of pages, what would you do? And so we're going to take the equation and we're going to substitute the number of chapters in for x, and then we're going to simplify to find out how many pages. And so our equation was y equals 10x. We're going to substitute x with 26 because that's how many chapters they're looking for. And so I would take that, multiply, and I get 260 pages. And so the question up above, is this prediction an example of interpolation or extrapolation? Well, I'm not saying right. Extrapolation. When you make a prediction that's outside the data you know, you're extrapolating the predicted value. If you're when you're using a trend line or its equation to predict a value, then it's interpolate. And so it is interpolation because we use the equation. Let's make a prediction. How many pages would be in a book with 14 chapters? Okay, so if you think that there's going to be 140 pages, that's what I got. Is this an example of interpolation or extrapolation? I think it's interpolation because what I did is I took the equation from our trend line and I figured out that 10 times 14 is 140. Do you think that extrapolation or interpolation is more accurate? And I think the only way that you can get an extrapolation of this would be if you found books in a bookstore and you had found like maybe 10 of them that had 20 chapters or 26 chapters or 14 chapters, whatever it is, but to have the same number of chapters and then look to see how many pages were in that book and then take a look at that. Did there seem to be some type of a trend going on or not? Okay, so extrapolation, you're taking it from samples pulled from shelves, and interpolation is when we're taking that information from a trend line from previous information that we've gathered, and you're finding the amount of pages from that. Okay, so there's two different ways of looking at that. One last one we're going to do here. It says use the diagram and description to complete exercises 1 through 5. 2 students found equations for trend lines for the scatter plot. Clarice used the ordered pairs 0, 13 and 24, 5 for her trend line. what equation did she get? And so what we're going to do is we're going to find our slope, and then we're going to find our y-intercept, and then we're going to write our equation. So go ahead and do that now. So I took the 2 points that she had for her line, and I found the slope, which is 1/3. And so my slope is 1/3, and I see that I had a y or an x as 0, and I know that that's going to be my y-intercept. So that's 13. So I have y equals 1/3 x plus 13. Anthony says that the ordered pairs 12, 10, and 24, 5 for his trend line. What equation did he get? So go ahead and find your slope and y-intercept for that one. So I took the 2 points and I found my slope, which is a -5/12. And then I plugged in the second ordered pair because I felt like it worked better with 5/12. And so over here I'm showing my work. I simplified, and -5 times 2 is -10. So I have 5 equals -10 plus b. Solve for b, got 15. So my equation is y equals -5/12 x plus 15. So now, they use their equation to predict the value of y when x is 36. What values did they each get? So go ahead and solve for Clarice and for Anthony. So I plugged in for Clarice's equation of y equals -1/3 x plus 13. I plugged in 36 and solved and found that y is 1. For Anthony, I took his equation of y equals -5/12 to x plus 15, substituted x with 36, simplified that. -15 plus 15 is 0, so y is equal to 0. When Clarice and Anthony use their equations to predict the value for y, when will Clarice's prediction be greater than Anthony's prediction, and when will Anthony's prediction be greater? And the best way to do that is to graph the lines. So I'll do that. Hold on a second. Okay, so what I did is I drew Clarice's line in red so you can see, and then I did Anthony's in blue so you can see his. And what I notice is that Anthony's is higher than Clarice's until they get to this point right here. And then that's when it switches where Clarice's is actually higher than Anthony's and Anthony is lower than Clarice's. Okay? And so when would they use their equations to predict the value for y? It would be at 24/5. Okay? All right, I believe that's enough for today. If you have any questions, please make sure that you're talking to your teacher. With the trend lines, you want to make sure, the important thing is to make sure that you're getting the same number of dots on both sides, or as close as you can when you're drawing them. If you have any questions, talk to your teacher. Thanks. Bye.